Okay, so in this experiment, we have the vibrating blade. I have it set actually now so it's vibrating up and down. And it's vibrating at a frequency of 60 hertz. So it's 60 cycles per second, or 60 times per second. And then we have the length here set so that the length from the vibrating blade to the pulley here is exactly 1 meter. And given the right conditions, which means the right tension in the string, we want to set up what we have, what we call a standing wave. And in particular, we want to observe just one loop, which is half a wavelength. Okay, so at this point, I'm going to start adding mass. Remember, the hanger is already 50 grams. So I'm going to add mass until I get exactly one loop. You should be able to see this. Hopefully it'll be clear enough. And it looks like right there is pretty good. So I have basically a node right at the vibrating blade. There's a node. There's another node at the pulley. And then I have an antinode right in the middle where it's vibrating the most. So you should see like a single loop now. And the amount of mass I have on the hanger is 1,150 grams, so 1.150 kilograms. Okay, so now we want to do the same thing. We want to adjust the tension, so adjust the mass, so that we observe exactly 2 loops, right, which is exactly going to be 1 wavelength of the standing wave. So I'm going to take this off, and let's figure out what we need to put on to observe 2 loops. And actually, we know from the theoretical arguments that it's going to be about 1/4 of the tension required to produce 1 loop. So I'm going to start with about that amount. So I have 250, 270, 285. It's oscillating a little bit because the weight is swinging, but so you guys should see now 2 loops where we have another node right in the center here. So antinode, node, node. Okay, so that was 285 grams or 0.285 kilograms. I will post all this data online. Okay, now I want to observe 3 loops. So now, again, theoretically, it should be around 1/9 of the tension required to observe 1 loop. So I have, let's see, 120, and then 130. Actually, 130 works pretty well. So again, now if you look closely here, you should see a node, 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 and then 3 antinodes, right? So basically 3 loops total as it's oscillating back and forth. All right, so that was 130 grams or 0.13 kilograms. And then finally, we want to observe 4 loops. So let's figure out how much mass we have to put on to observe 4 loops. It should be about 1/16, right, of 1150. So I'm going to try, I think it's a little over 70. I'm going to try 75 grams. Actually, that's pretty good. So 75 grams. It looks like we're observing 4 loops. Okay, so 75 grams, which is 0.075 kilograms. All right, so that's the data that you need for this part of the lab, and the other values you can calculate yourself. Great.